So today we'll be learning about improper integrals. Now, improper integrals are defined as an integral where its upper and lower limits either have a positive or a negative infinity. Um, Typically, whenever we learn about integrals, we're taught about definite integrals. And definite integrals have upper and lower limits that have real numbers. So you can have 0 as the lower limit, you have 5 as the upper limit. You can even have negative numbers, so you have -1 and a positive number. You can even have decimals, so you can have a 1/2, fractions or decimals, so you can have 0.5, or the lower limit can be 0.25. But the point here is that in this case, when we first learned about upper and lower limits on integrals, these are all real numbers. This symbol here means real numbers. So, real numbers. And so real numbers encompasses your decimals, your fractions, your negative numbers, any number going from negative infinity all the way up to positive infinity is considered a real number. Now, the issue here is that infinity is not a real number. It is not a real number. Not a real number. Made a little mistake right there. It is not a real number. Okay? And that's the key important fact that we need to remember today, is that because infinity is not a real number, we're not allowed to perform the antiderivative and evaluate this integral the normal way we usually do it. And typically with improper integrals, you can have one that has a lower limit and a real number. You can have an upper limit and a real number. You can even have both. The bottom limit is negative infinity and the upper limit is positive infinity. So if we were to evaluate this, not evaluate, but take the antiderivative of this, you'd have, it's negative. An improper integral that would look like this. And as I've said, infinity is not a real number, so you can't just plug this in here and think everything's going to work out fine. Whenever we're working with infinity, the proper way to evaluate is to use limits. If you ever see an infinite sign, just remember that limits are an absolute must. You cannot evaluate any function without using limits because it's not a real number. So I would say the literal proper way to evaluate this is to rewrite it as a with infinity as some new variable. So that's what we'll do here. So this is what we're given. This is the equation that we're given. Now we're going to rewrite this entire function as a limit. So I'll explain what I did here. So let's go with green. So first step that I did is that I replaced. Ooh, little oopsie there. I replace infinity with some variable. I'm just going to abbreviate variable there with variable t. And you can see that here where I have this infinity here. And I replaced it with some variable. It could be whatever variable. I just chose t. I like t. So, and then what we do next is we take the limit as t goes to infinity. And that's what we did here with this t. So down here we can see that t is going to infinity as a part of this limit. And so now what we can do is now we can take that antiderivative. I'll keep it green to make my point. To make my point that this is the proper way of taking the antiderivative of an improper integral. And now we have from 1 to t. And since we have some variable here, we've also learned that you can take an integral with some upper limit of some variable, because if you wanted to find an area under the curve, you now have the antiderivative with some variable, and you just find what your upper limit is. You plug in your upper limit. Now you can find your area under the curve if you was to plug it in. So I'm try to scroll down, make it easier to visualize. Don't want to go too far down. Okay. So now we can evaluate this. So this will be equal to limit of t goes to infinity, and now you'll have negative 1 over t minus a negative 1 over 1. And if we were to insert, now we can insert infinity into this. Negative 1 over infinity minus negative 1 over 1. Now we know that any number divided by infinity goes to 0. 1 over 1 is 1. That's negative 1. And negative and a negative is a positive, so we're left with a positive 1. So what this means is the limit of t little technical difficulties here. The limit of 1 over x squared, a little too close for comfort, so limit of 1 over x squared dx as t goes to infinity. It's doing it again. I guess it's not being nice to me today. Let's try the mouse instead. As t goes to infinity will be equal to 1. And that's how you solve a improper integral.